Alright, this video we will discuss solving absolute value linear equations. Alright, here I'm assuming that you are familiar with the basic concept of absolute value, and obviously this is an equation because you see equal sign and you obviously see absolute value sign. Okay, that's why we call this absolute value equation. All right, before we begin, I want to quickly point out a real basic fact about absolute value. Let's say I give you this equation. Absolute value of x is equal to 3. All right, if I ask you to solve this, that means find a value or values of x whose absolute value is equal to 3. And you may say, well, that's pretty easy. There, x is equal to 3. Also, x is equal to -3. That is true. Okay, quick point about notation. Here we have two different values, 3 and -3, assigned to a same variable x. That is usually not a very good notation. So what I'm going to do is differentiate. First solution is 3, second solution is -3. So x1 and x2. Okay, I'm going to continue to do that during this and maybe several more coming videos. All right, okay, and of course what we are saying here is then the x value, I can simplify this as x is equal to, instead of writing two separate 3 and -3, I can say plus or minus 3 and say this is my solution set. Or sometimes some teachers want you to write the answer in so-called roster form like this. All right, either one is any one of these is fine. Okay, I'm going to use this idea right here to solve all of these problems. For example, it tells me that I take out my so-called the argument of the absolute value. Again, argument means anything inside this absolute value in this situation. That is taken out, absolute value is removed, and that is equal to 2 plus or minus 3. So I'm going to use that idea to solve this. So I take out the argument, which is just 2x minus 3, and that is equal to plus or minus 4. Okay, I want you to kind of see the comparison between what I did there and what I did right, what I wrote right here. Okay, all right, and I'm going to just solve this. And this now, what I have is a basic linear equation where I add 3. Okay, so what I have is 2x minus 3 is equal to 3 plus or minus 4. Now that's going to give me two values, 3 plus 4, which is 7, 3 minus 4, which is -1. Okay, oops, hang on a second, that shouldn't be here. Yeah, there you go. 2x is equal to 3 plus or minus 4. All right, okay, and all I need to do is now divide by 2. All right, so what I have is x is equal to 3 plus or minus 4 over 2. Okay, that looks a little confusing, so let me go ahead and write this as two separate answers. First, my first solution is 3 plus 4 over 2, which will be 7 over 2. So that's my first solution. Second solution, x2 is 3 minus 4 over 2, which is -half. All right, so I arrived at two separate distinct solutions, one here and one here. I'm going to write my answers explicitly like this. My first solution is 7 over 2. My second solution is -half. All right, again, alternatively, you can write that solution as roster braces 7 over 2 and -half. All right, okay, so that's our first problem. And the second, okay, here we have a fraction. So I'm going to start this by taking out my argument is equal to plus or minus 3. Okay, again, we've seen this anytime that you have a fraction, you can just multiply by the denominator, and that should cancel out our fractions and gives us 5 4 minus 5x is equal to plus or minus 18. All right. All I need to do is subtract 4 on both sides. Okay, so I have negative 5x is plus or minus 18 minus 4. Again, I'm going to leave it that way for now. And our x can be isolated by dividing by negative 5. All right, so that's going to give us two solutions. First, x1 is, I'm going to take the positive 18 minus 4 over negative 5, which will be negative 14 over 5. All right. Second solution, negative 18 minus 4 over negative 5, which is negative 22 over negative 5, or 22 over 5. All right, so let me write my solutions. x1 is negative 14 over 5. x2 is 22 over 5, or in a raster form, that should be negative 14 over 5, comma 22 over 5. All right. Okay. All right. This third problem is a little bit more messy. It got a lot of stuff with that absolute value. Okay. One of the things that I want to warn you is do not distribute anything into the absolute value. Algebraically, you come out okay, but we try not to do it that way because the absolute value usually means it's a distance concept. All right. Okay, so instead what we're going to do is first isolate just this absolute value part of the problem. Okay, just isolate this. That means we have to subtract 5, okay, on both sides, and then divide by negative 2. Okay, let's go ahead and perform that. So first, subtract 5. So we have negative 2, absolute value 3x minus 4 is equal to negative 10. And then divide the whole thing by negative 2. That should give us absolute value of 3x minus 4 is equal to positive 5. And now this problem has turned out something similar to our problems to, actually definitely problem number 1. Okay. All right. So from here, now we will take 3x minus 4 is equal to plus or minus 5. Add 4 on both sides. And that should give us 3x is equal to plus or minus 5 plus 4 divided by 3. And have x is equal to plus or minus 5 plus 4 over 3. And again, that should give us two solutions. x1 is positive 5 over 4. I'm sorry, positive 5 plus 4 over 3, or 9 over 3, or positive 3. Second solution, negative 5 plus 4 over 3, or negative 1/3. All right, so let me write my solution as x1 is equal to 3, x2 is equal to negative 1/3. Raster form 3 and negative 1/3.